Hi, Arun. So are we good to go now?
Yes, hello and welcome everybody to today's session of ICSC 2022. And we are here in the focus session of requirement engineering. So we are about to start the first talk or presentation. So the title is How Templated Requirements Specifications Inhibit Creativity in Software Engineering. And Rahul will be presenting the talk for this particular paper on behalf of his co-authors. So go ahead. You have 5 minutes. And when you reach 4 minutes, I'll post a message in the chat box just to, inform you about the passing time. So please
Thank you,
go.
Arun. Thank you, Arun. Hello and a very good morning to everyone from Finland. So let's go through the major aspect of a recently published paper in IEEE TSA. So first, let us look at the motivation and the problem that we were trying to target. So a few years ago, we were observing a development team responsible for development of a mobile application, where the client actually gave a very unclear list of features and instructions as requirements. The developers began coding the system, and the client eventually rejected the application altogether. So we observed the following reasons. Well, most of the requirements were actually deceptive, ambiguous, and the developers immediately accepted the requirements without actually critically analyzing those requirements. So we speculated that the way in which these requirements were presented affected developers' cognition. And this could be then explained by framing effect, which is a type of a cognitive bias. So overall, we wanted to investigate whether designers might be fixating on specifications when it will be framed as formal requirements. So to test a hypothesis, we conducted two experiments where we compared the list of specifications framed differently, first as a list of formal requirements and then as uncertain ideas. And for the second experiment, we had the same list now framed as a list of prioritized requirements. And we measured the creativity in terms of originality and practicality. The results of both the experiments showed that the designers fixated on specifications, which reduced their creative performance. However, the experiments were only suitable to then establish causal effects, but not to understand the cognitive mechanisms. Here, we needed a real-time insight into software designers' cognitive process. So, our research approach. We conducted a dialogue-based protocol analysis where participants were working in pair and verbalized their thought sequences. We had a convenient sample of 18 professionals and 24 postgraduate students. We used exactly the same task as our previous experiments, where participants were asked to develop a mobile application from the given list of requirement specifications. The recorded dialogues were then analyzed in two phases. First, inductive or process coding, which was used to explore the cognitive actions used by the participants, and deductive close codings, which was actually reanalyze the data based on the existing literature on fixation and critical thinking. So the overall findings, the open coding produced 7 themes, each of which we interpret cognitive activity, and we found 1,006 instances of fixation compared to 298 instances of critical thinking. We also analyzed the differences between the students and the professionals. Well, both the students and professionals seems about equally susceptible to fixation, and more experienced developers are more prone to fixation. And basically, we then propose an overall theory where we conclude that by providing designers or developers with templated requirement specifications, which are basically requirements or specifications framed formally, would result into hindering the critical thinking and thereby negatively affecting the creative potential of the developers. In this paper, we also advance our theory and we present the cognitive actions used by developers while designing any kind of system from the list of requirements. And that's about it. Thank you very much. I guess I'm well under time.
Yes, you are almost, in time. So now the floor is open for discussion. If the panel members have any questions. Okay, just to break the ice and just to start, I have a few interesting, observations from your work. Although it's a very interesting thing, very interesting findings that you have just discussed with us. Just tell us about your participant selection criteria. Like, how did you select your professionals, and how did you manage to select the students? What was the criteria?
Thank you, Iram. So yeah, it was a convenient sampling. So we didn't target any specific population. The students were selected from my postgraduate course in my university, which had some experience on design thinking and design process, but not any kind of experience with the actual task. On the other hand, the professionals were then chosen or recruited from a company, and one of the co-authors is actually a part of that company, and that's how we chose the professionals as well. So it was a convenient sampling, and the pairing was actually done based on availability. So again, there was not a hard set rule to pair the participants together. However, the professionals were paired with professionals, and the students were paired with students. So there was not kind of a mix match between professionals and
Right.
students.
And would you like to talk about just a little bit about the generalization of your results?
Yeah, so it's actually it's actually interesting to generalize. So we are not trying to generalize our results to the entire population. However, what we have also mentioned clearly in the paper is that we want to propose an observation. So it's a very critical realist approach. We are not trying to conduct an experiment so that we can easily generalize to the actual population. So this was kind of a qualitative study where we are proposing a theory from the observation rather than generalizing it to that this is what happens with the entire population.
Right. Thank you so much. And anybody else interested in discussing the content of this particular presentation? Okay, we have another question written in the chat box. Can you read that?
Yes, I can. Just sorry, sir. I do not understand what does it mean by at fault. Yes, so actually, when we say templated requirements, so okay, if I understand the question correctly, when we mention templated requirement specifications, what we are trying to say is requirements when are presented in a very formal, restricted, and constrained way, or written in a very constrained and formal language. Now, I didn't mention as a part of a presentation, or I did actually shortly, but then the causality was established that the formal requirements is affecting or kind of affects creative potential in the two experiments that we conducted. So we take this thought forward to our current study where we try to investigate why this thing is happening. Um, I guess the way the requirements are presented to the developers or to the participants is what we feel is the problem. So it is the language, it is the way the requirements were presented. So we basically used a very straightforward way. We use the phrase the requirements shall, or the feature shall versus the feature could or the feature might do something. So this is what we basically see in the experiments and in the current study, the distinguishing major factor between the two groups, or what the effect is seen because of it. Bashir, I hope I was able to answer the question. If not, we can definitely take it forward. Thanks a lot. Thank you.
Okay. We have any other question before we jump to the next presentation? Okay, right. Thank you, Rahul, for the wonderful presentation.
Thank you.
Okay, we have one more question from Martin. Recommendation on how to represent requirements.
Yes, Martin, thank you very much. Yeah, it's a very interesting question, and this is what I'm trying to do now. This is what we are trying to work on now, and also this point, exactly the very point, is also mentioned as a part of the future research avenues in the paper. So we'll wait and watch. At least what I can say is that the more formal or the more structured the requirements are represented as, the lesser creative or it kind of affects creativity in a very significant manner. So how to best represent the requirements? There's something still unanswered and something which we should kind of focus on next.
Thanks.
Okay, thank you, Rahul, for the wonderful presentation and for a very good discussion on your paper. So now we'll move to the next presentation for today's session. That is the paper titles as On Systematically Building a CNL for Functional Requirements. And yes, Alvaro is here to present the paper. Yes, please, start. You have 5 minutes.
Hello, I am Alvaro Beizaga from the University of Luxembourg, and I will present our paper entitled On Systematically Building a Controlled Natural Language for Functional Requirements. This work has been done in collaboration with Mauricio Alferez, Damiano Torre, under the supervision of Lionel Briand and Mike Sabet. Requirements are crucial in all software and system development projects because they state the necessary characteristics and qualities of a system. Most software requirements specifications are written in natural language. Some studies confirm that 71.8% of software requirements are written in natural language. This is because natural language can be used in all application domains and understood virtually by all project stakeholders. The quality of a software system greatly depends on the quality of its requirements. High quality requirements improve the system quality, the return of investment, and the customer satisfaction. On the other side, having missing, vague, inconsistent requirements may cause projects to fail, excessive maintenance costs, or disappointed business users. The problem we address in this paper was motivated by practical needs observed across many industrial domains. For example, our industrial partners reported us that several communication and delays arise from requirements that are not stated precisely enough. In this paper, we develop a controlled natural language named REMAY for writing functional requirements. REMAY aims at to improve the quality of requirements. This is our systematic methodology to define our controlled natural language, consisting of 5 steps. First, we extract requirements. Second, we identify codes and their corresponding verbs. A code identifies a group of verbs that share the same information content in natural language requirement. Third, we manually label the requirement extracted in step 1 with the codes identified in step 2. 4, once we have labeled all the dataset, we group requirements that share the same code to better identify information content amongst requirements. And 5, once we identify the information content of requirements, we derive grammar rules. For our empirical evaluation, one of the research questions was about determining how well our controlled natural language can capture requirements of previous unseen documents. To answer this research question, we conducted an industrial case study with our partner ClearStreet Luxembourg. We follow an iterative process consisting of 4 steps where the goal was to rephrase requirements that have not seen before using our REMAY language. We calculate the number of requirements that were rephrased using our language, and the table shows that REMAY is expressive enough to capture on average 88% of the natural language requirements statements in 4 previously unseen software requirement specification documents from the financial domain. We also kept track of the requirements that we were not able to rephrase using our control natural language, and we annotated each requirement with one of the following three causes. Cause 1, the requirement contains a verb that is not supported by our language. Cause 2, some information content, excluding the verb, is not supported by our language, remain. And cause 3, the meaning of the requirement is unclear and no financial analyst could clarify it. As conclusions, we point out the following aspects. The quality of a software system greatly depends on the quality of its requirements. Control natural languages, compared to conventional requirements patterns, provide structure with more specialized concepts and constructs. Control natural languages strike a balance between the usability of natural language and the rigor of formal language. Control natural languages enable automated analysis such as test case generation and model generation. And our evaluation shows that REMAY is expressive enough to capture most of the unseen requirements from the financial domain. Thank you very much for your attention. Okay, for answering the question that was posed in the chat. Let me.
Can you read that out?
Yes. Will representing requirements also bring about 80% of the possible benefits or more or less. So regarding the benefits in our study, we didn't conduct any study regarding that because our language has not been started yet using by our industrial partner. Nevertheless, during the evaluation, we validated with them the feasibility of using our language to represent functional requirements. The second question, did you study if remake can be easily extended to support the requirements it was not able to support or something in the language prevents it? Of course, there is no control natural language that support all type of requirements. Nevertheless, for building our language, we use a large set of requirements from the financial domain. And also we, for the structure of our language, we rely on not domain specific lexicons such as Burnett, so that to make our language more usable for other domains. But of course, also in the paper, we have described our systematic methodology so that it can be used as a starting point for building or extending our language to other domains. There is another question. Control natural language are quite common in industry relating to the previous talk. How do you know it is constraining feature of the specific language and not the increasing formality that it is adding value? If I understood correctly, control natural language restrict the creativity of the people because we vocabulary, restricted keywords, but we do that in order to enable other things such as automation. For instance, we have already used our language to derive acceptance criteria from text. There is another question: how much time is needed to build control rules? Is it done manually or automatically? In our case, we did manually, so it took us several months because we have to read and analyze to extract the structure of the functional requirements from the financial domain to derive rules that build our grammar, which is called remain. And there is another question. So we have to choose between automatic verification versus creativity. Yes, yes. So we have to choose that. And there is another one. So it will be very interesting to investigate the balance between getting automation done versus creativity. Yes, that's a good point. That's too big.
Yes, I think that says that there is no silver bullet. So you have to maintain the trade-off, either creativity or formal verification. So there is another question.
What is the difference to existing template-based languages such as EARS? So we were inspired by EARS, the templates, because they require less training and they are well known in the requirements community. So some of the rules of our language are inspired by EARS. And we have some overlaps, but still we have another rules that are different, and these rules make our language.
Wonderful. So I believe we are done with the questions for this session. We had a very fruitful discussion for your paper. Thank you for the wonderful presentation, Alvaro. Thank you so much.
You're welcome.
We'll jump to the next paper for today, that is Deep STL, from English requirements to signal temporal language, signal temporal logic.
Yes.
It means this is again more towards the formal verification or formal presentation of requirements. So yes, are you ready, Jay?
Yep. Okay. So can I start?
Yeah, please go ahead.
Okay, let me share my screen. Okay. So can anybody see my screen? Okay. So hello everybody, I'm Jay from TU Vienna. It's my pleasure to present our accepted paper that promotes the application of formal methods in requirements engineering. Our work aims at translating English requirements into signal temporal logic to enable the compatibility between documented requirements and its input to existing runtime monitors. So to this end, building a data set and training an AI model constitute the main scope of our work. So we started with the empirical study for both STL and English requirements in literature. To address the scarcity of training data, we then developed a workflow to generate a parallel corpus as shown in the bottom of the two columns. Then we employed a transformer-based AI model to train the translator and compared its performance with other models such as seek-to-seek and attention. And we developed a specialized tokenization method so that words in the corpus can be efficiently encoded. This slide shows the testing metrics of the translator. We firstly tested the three models on synthetic data. We found that for attention model and the transformer, they can achieve very good accuracy, with transformer performing a little bit better. However, when we did extrapolation tests in real examples, the translation accuracies of all models dropped considerably. So despite the loss of performance, we can say transformer still does the best job. So this is a slide shows the testing results of transformer. As we can see, when the input language is very similar to the sentences in our dataset, the translation quality is very high, and the translator can even process synonymous requirements. So, however, when the style of the input language is different from our dataset, as can be seen in our extrapolation test, all models will probably make mistakes. In the first example, we can see transformer translates correctly, while the attention model fails to copy the identifier and the number and even mistranslates the greater than into smaller. The seek-to-seek model fails to translate anything. In example 2, transformer tends to add an additional keyword called rise, while attention model would also reverse the meaning again. Still, seek-to-seek performs very badly. So for the third example, transformer translates correctly while attention makes the same mistake. So we think there are two possible future directions. So the first is related to AI. You can see deep learning performs well when the testing data is similar to what have been trained. However, once the testing data is different from the training data, its extrapolation performance is very poor. This problem is not so obvious for general commercial tasks where there's a huge amount of data available. However, for industrial applications with limited data, how to build a more interpretable and accurate learning mechanism is an interesting direction. The second question returns to the role of requirement engineering. The real situation is always more complex than what is conveyed literally. Take me as an example. I suffer from gout, which may cause acute pain in the foot ankle. And nearly every medical guidance would require a man patient to limit his uric acid down below 6. If we know it's the requirement, can we be a doctor ourselves? Probably not, because we need a doctor to make the proper diagnosis according to comprehensive factors. So compared to practice of engineering, which is also complex. I think requirements engineering may need to play a more proactive role in the whole life cycle of the V model. For example, we should distinguish what is real important requirements in different phrases and how to evaluate positive and negative results. How much tolerance can we accept? Obviously, we need domain knowledge to know what is behind the context, as we need a doctor to treat the disease rather than merely relying on the guidance and the text. So thank you very much for your attention.
Okay, we have you. What is the difference between formula accuracy and template accuracy?
Okay, so formula accuracy is absolute accuracy, word by word, symbol by symbol, and template accuracy, as every formula has grammatical templates, so we can transform the formula into a template. So the errors of identifiers and numbers may be masked because they all belong to a symbol called phi. So, and generally speaking, template accuracy would be higher than formula accuracy, and the template accuracy would reflect the structure of the translator, whether it grasps the main grammatical structure of the language. For how did you get the training data? I generate myself. I built a generator, and so it took me half a year to build a generator that can automatically generate corpus in parallel corpus, because to the best of our knowledge, there's no such data set available, and it is very expensive to help some person to build a data set because not many people know what is STL. So this is the problem. Validate the auto-generated data. So for the for this validation, we do in the test. So we validate the testing results, testing performance on our synthetic data. That's the auto-generated data, and then we also do extrapolation tests. So in our paper, we found 130 real examples in literature, and selected 14 examples in the real world for testing. So as you can see, the extrapolation testing, there are 3 examples. They are all from the real examples, but they will also make mistakes. Did you study your system's behavior on different formulation of the same requirements made by different people? Currently, we only tested the synonymous expressions based on our in the testing. So how to say is I just write some synonymous expressions, and these expressions is very similar to what I had created in our training data set, so this will be fine. But if you say me, I write the specification, you write the specification, we have totally different language habits, so maybe the translator will not work because what we have written is not similar to what have been trained, so that's the problem.
And what was the size of data?
How
many expressions did you create?
How many so you mean the volume of the training data? Yeah, about 100,000 parallel corpus, 100,000. It's a very small data set of comparing to natural language translation. Okay.
Right. We have 2 more questions for you in the chat box.
Okay. Why do you split identifiers and constants? Okay. So this is a common. So I just adopted a subword tokenization method. So if we prepare a vocabulary, as we know, as you can see, there are infinite permutations of how I can write the identifier and the constant. We can never use a limited vocabulary. So if we can split identifiers and the constants, so we can only use the letters and the numbers to encode the identifiers and the constants, so that we don't need to prepare a limited vocabulary. So this way it can handle identifiers and the constants. So your system needs training for each person formulating the requirements. Not really. So the scarcity of training data is the first step, and since now we have a lot of training data available, we can use automatic data augmentation method in natural language processing. So that technique would consider many people's language habits. So we hope this way can augment more data. Since there's a data available problem, so do you intend to make your generated data public? Yes, as you can see, you can see my paper. There's a public link. You can download my data and okay to say how it looks like.
Right. If we have no more questions, so thank you, Jay, for the wonderful presentation and for sharing the interesting results with us. I think now we are good to jump to the next presentation for today's session. That is automated handling of anaphoric ambiguity in requirements in multi-solution study. So I'll invite the presenters to please start. Yes, Saad, are you going to present?
Yes. Hello, everyone.
Please go ahead.
Okay, let me share the screen. Yeah, hello, everyone. My name is Saad Zini, and I will present our paper, Automated Handling of Anaphoric Ambiguity in Requirements, a multi-solution study. First, I will start by reading this requirement specification excerpt from a developer point of view. The SNT component shall send all approval requests to the DBS. If the request contains storage parameters, it shall create a configuration record from the parameters. So in this paragraph, to know what to implement, the developer must know which subsystem should create the configuration record there. We define antecedents as the preceding entities that the pronoun refers to. So in this case, the possible antecedents for the pronoun it are the SNT components, all approval requests, DBS, the requests, and storage parameters. After eliminating the obviously wrong ones, we still have 2 candidate antecedents that are left, which can lead to 2 different implementations. So without domain knowledge, the developer is unlikely to correctly disambiguate the pronoun it. And this is anaphoric ambiguity. So as we have seen, anaphora is prevalent in requirements. It occurs in around 25% in our data collection. It needs domain knowledge, which is not adequately captured by all involved stakeholders. So we developed and experimented with 6 solutions based on language models, machine learning, and off-the-shelf NLP tools. And we empirically evaluated these solutions on 2 datasets. For the problem definition, we defined problem with 3 components: the pronoun, which is the problematic pronoun, the context, which is the requirements containing the pronoun, and the preceding one. Candidate antecedents are the preceding noun phrases that comes before the pronoun. So we have 5 that are highlighted in this example. So in our work, we handle ambiguity via 2 tasks. Anaphora ambiguity detection. Its goal is to detect whether the pronoun is ambiguous or not. Anaphoric resolution, which tries to identify the correct antecedents for a pronoun. So for our solutions, as we have said, we have 6 solutions. The first 2 are based on span BERT, which is a language model, a variant of BERT optimized for span selection. The first one, span BERT NLP, is fine-tuned on a large NLP dataset. The second one, span BERT RE, is basically the span BERT NLP fine-tuned again on a smaller RE dataset. The inputs of these models are context and pronoun pairs. The outputs are text spans, which are the antecedents with prediction probabilities for each. For the 3 next solutions are based on machine learning. The first one uses language features that we gathered and enhanced. So we use more than 40 language features. For the first solution. The second solutions use feature embeddings that we extract from sentence BERT. The third one, it combines the first 2 in an ensembling fashion. So we have 3 machine learning solutions. They take all inputs, the triplets of context, pronoun, and candidate antecedents. The outputs are these candidate antecedents classified either correct, incorrect, or inconclusive. We therefore apply some set of rules to derive the label, if the pronoun is ambiguous or not. For the last solution is we use off-the-shelf NLP tools in a combination. So we use 2 coreference resolution tools. We combine their outputs. If both tools agree in the outputs, if both tools provide the same resolution, then the pronoun is unambiguous and the resolution is the one that they provide. If not, if they disagree or provide different resolutions, then the pronoun is deemed ambiguous. For evaluation, we evaluate our dataset, our solution on 2 datasets. Damir, which is our contribution from 22 software requirements specifications and 8 domains. It has more than 700 pronouns. The second one, Rekeval, which is a public dataset, it has around 100 pronouns. So for the first research question, we assess whether which solution alternative is the most accurate for detecting anaphoric ambiguity. Comparing to other alternatives, machine learning solutions are the best performing on both datasets, as we see. And we can consider machine learning ensemble as the most accurate solution for anaphoric detection requirements. For the second research question, we evaluate the anaphoric resolution using 2 types of accuracy based on full match and on partial match. So as we see, the span BERT based solutions outperform the other ones, and in particular, span BERT RE has a slight edge over the span BERT NLP. So in conclusion, we have seen the importance of anaphoric ambiguity requirements and how problematic it can be if left undealt with. Our findings reveal that language models do not always outperform traditional supervised machine learning methods in this task. And also, as we have seen, combining language models with machine learning in one solution is promising. Thank you.
Thank you, Saad, for presenting your paper. Now the floor is open for discussion. Now we have 2 questions in the chat box.
Okay, the first one, not all ambiguities are of the same severity. Do you have any heuristics for distinguishing them? I hate to mention this, but there is a related work in this area. Like, yes, well, our work, the combination of machine learning models are based on the rules that are provided by the paper you mentioned. It is well cited in our work. We don't have a heuristic for distinguishing the severity of anaphoric ambiguities. Yes, but our work tries to detect the problematic cases, not all anaphoric, not all cases that contains anaphora. For the second point, proponents of template-based specifications would agree that requirements containing anaphora, as shown in your example, are bad per se and should be rewarded. So, in this perspective, actual detection anaphora would survive. That is true, but since we, in our tool, maybe an analyst would like to access like suggestions for resolution, it might be a nice addition. Any other question?
Okay, so what was the size of data set that you used for this particular paper?
As we said, we have our data set that we built. It contains more. It is built from 22 requirement specification domains,
Okay.
from 8 domains, and it has around 700 pronouns.
And would you like to, give your 2 cents on why your results are more towards machine learning, that machine learning models are outperforming the rest? Would you like to give your opinion about that or make a small discussion about that?
Of course, traditional methods that are based on NLP heuristics are now, you can say that are outdated. Since the last years, we have a huge success of language models and machine learning solutions. So I think this is and this was the reason that why we wanted to investigate this topic, because the solutions that are already exist are a bit outdated.
Right. Thank you so much for sharing interesting results with us and for having a very good discussion on your paper. Thank you, Saad. Now we'll jump to the last paper for this session, that is automated labeling and classification of business rules from software requirements specification. And I'll invite the presenter, Pretu, to start the presentation.
Yeah. Hi, everyone. Am I audible, visible, and is my presentation visible?
Yes.
Yeah, okay. So, hi, everyone. I'm Rose Anish, and I'm from TCS Research, India. I'm here to present a paper titled Automatic Labeling and Classification of Business Rules from Software Requirement Specifications. So, let me start by giving you a brief summary. Now, business rules, as we all know, is a critical artifact in the requirements elicitation phase of software development lifecycle. Several initiatives aimed to address aspects such as organization, representation, and classification of business rules can be found in the literature. So, one of the very popular schema, which is very comprehensive and a clear taxonomy, is the Ross's classification schema for BRs. So, in this work, we have adopted Ross's classification schema, and we present an approach to automatically label and classify BRs along the schema. Towards this work, we have used a Snorkel, which is which helps in automatically generating labeled training data. We experimented with 2 deep learning based models, namely BiLSTM with attention and BERT, to classify the BRs. These models were evaluated on industry specific data sets, which comprised of business rules from various business information system domains. And in our case, we obtained highest F score with BiLSTM based model. Coming to some details about data collection and labeling. So we took help from 3 in-house subject matter experts. We took a total of 210 publicly available SRS documents, and the SMEs helped us extract around 6,000 BR instances from these documents. So these documents belonged to different application domains. The SMEs then manually labeled a very small portion of these BR instances, that is around 700, and the remaining instances were auto-labeled using Snorkel. Now, as many of us would know that Snorkel makes use of labeling functions. In this work, we created a total of 90 labeling functions, which were based on keywords machine learning based techniques and some deep learning based techniques. And we experimented with several combinations of the same. These LFs, the created LFs, were analyzed using the standard metrics such as coverage, overlap, conflict, and so on. And based on these metrics, we selected the top 14 labeling functions. See in the table, the average accuracy, the average labeling accuracy was around 73.28%. Validation of snorkel labeled data. So once the labels were created, we wanted to check the generalizability of the labeling functions. And in order to check that, we need to check the generalizability of the BR classes on which these labeling functions are based on. So for this, we took help from 3 in-house domain experts. And we asked the experts to tell us whether the BR classes, the 7 BR classes which we had taken, are domain agnostic or domain specific. Now, all these experts were of the opinion that all the 7 BR classes are domain agnostic. That is, they would be present in all the business domains. In addition to this, they also identified some classes which would be specific to, say, there are classes which would be specific to insurance domain or say security. So in case we want to adopt this approach for a particular domain, the LFs which were already created for these 7 classes can be reused as is. And in addition, for the specific BRs, which are specific to a particular domain, you might have to create additional LFs. As I said earlier, for classification, we trained 2 language models. One is BiLSTM with attention, and one is BERT. Now, hairy requirement tasks. So as suggested by Dan Berry in one of his papers, hairy requirement tasks such as BR, identification, and classification, these are not inherently difficult when performed by human on a small scale. However, when the scale is large, you need automation for such tasks. And for such tasks, essentially recall is weighed more as compared to precision. So therefore, we used measures of weighted F-score for calculating the accuracies. And since in our data set, the count of business rules was about 5 times less as compared to the non-business rules, we used F5 score for evaluation. And additionally, to measure the overall performance of the model, we also used metrizers such as Hamming laws, label ranking laws, etc. So in case of our data set and the optimization parameters chosen, we observed that BiLSTM with attention has performed better. 2 reasons for this could be: one, BERT has been known to perform better, but it is with data sets which are of, say, 100K instances. And here we are dealing with 6K instances. The other thing is about the high level of class imbalance which was there in our data set, and aggravated by the fact that we are dealing with multi-label data set. These are some of the threats to validity, and in the paper we have tried to address them to the maximum extent possible, like the comprehensiveness of the classes, since it's a popular repository, the BR repository. So we have validated them with experts. So the classes are comprehensive. Similarly, about the generalizability and the comprehensiveness of the data set. So one of the immediate future work that we would like to take up is to deal with class imbalance. We would like to make our models resilient to this because, I mean, this is inherent to the industrial data set. Business rule data set would be imbalanced, and we would want to tackle that. Yeah, so with that, I will stop my presentation. I hope I'm within the allotted 5 minutes.
And the house is open for discussion.
Okay, I can see a question in the chat. I can read out that.
Yeah, please go ahead.
So in the paper you mentioned, we extracted 5,000 instances from it. It is a huge number. How did you realize this? Are there any tools? For snorkel, what is the accuracy comparing to human labeling? Okay. So yes, it is a huge number, but since we work in industrial research, we have a huge subject matter experts. So if we do not do this automation for you, there's a team who manually does this tasks. So so extraction of 6,000 is also a smaller number because there are a huge number of subject matter experts, hired only for such tasks. And we through this work are trying to, reduce their effort. And the second part, which is snorkel. So as I said, I mean, these kinds of tasks, which are essentially hairy requirement tasks, if you give the entire set to a subject matter expert and you tell them to classify them as a BR or a non-BR, so they have to go through the entire document, as opposed to you generate these labels and give them labeled data, and if they are asked to just eliminate the ones which are, say, non-BRs, or which are wrong, which are wrong classifications, it is considered easier. What are the sizes of training and test set? So for the snorkel labeling, as I said, we asked the subject matter experts to label a very small portion out of these 6,000 instances, which was close to 719 rules is what they labeled. And out of that, the training and test size was 1:1 ratio.
Okay, do we have any more questions? Yes. It's about the test data.
Yeah, okay, where?
Is the test data manually annotated?
The test data is manually annotated, yeah, by the subject matter experts. So the test data size was around 1,200 business rules. So we had the ground truth for those. Okay, the training was done, as I said, there were 6,000 instances, right? So the training is done on 6,000 data instances, and the testing is done on 1,000.
So do you think the validity of your results slightly depend upon the expertise or the experience level of the subject matter experts that you have selected?
It depends on actually the labeling. As I said, I mean, only a small portion of it was labeled by subject matter experts, around 700 instances, and more than 500 instances were auto labeled. So ideally, it depends upon how snorkel performs.
Right. And do you think that your results are dependent on the kind of requirements that you have chosen or the kind of data that you have chosen?
Okay, so since we took 210 publicly available SRS documents, and we made sure those are from varied business information system domains. And what we observed is it worked well so there were around 7 domains from which these requirements were taken. So the results look quite generalizable. As per the subject matter experts, for every domain there will be certain business classes which are specific to that particular domain. So the tool needs retuning so that it also caters to those additional classes.
And those 7 projects or those 7 SRS or domains were different from each other, or they were all alike?
No, the 7 domains were like insurance, security, healthcare. These are the
Okay,
kinds of
information
domains we had.
systems. Right, information systems.
Yeah.
So maybe we can say that we can generalize the results only for information systems,
Yes,
not for
yes.
other.
Yes.
Right. Thank you, Preetu, for sharing interesting results with us. I believe
you
we
so
don't
much.
have any more questions. And with this, all the presentations for this session, end here. Thank you, everybody, for your presence and for your participation. It was an interesting session. It was really nice, looking into the interesting results that you guys have shared with us. So have a great evening.